All right, so finding the inverse of a function. So let's say we have a function, x cubed minus 5. So to find the inverse, the first thing we're going to do is we're going to write it as y equals x cubed minus 5 instead, because that's going to make our life a little easier. So f of x and y mean the same thing. Probably.
There was something like that.
Yeah. So you guys have done functions. We haven't done inverse functions, but.
Yeah, I think it was.
Okay.
Or maybe I just didn't know how to do it anyway.
Yeah. All right. That might have. Okay. Okay, so to find the inverse, you're going to switch x and y. So like everywhere there's a y, you're going to put an x. Everywhere there's an x, you're going to put a y. Because that's how you find the inverse. You swap them. Cubed. So we're going to write this, yes, as x equals y cubed minus 5. So switch x's and y's. Then we're going to solve for y. So we're going to solve our new equation for y. So we're going to get y by itself. So to get y by itself, we're going to have to add 5, right, to both sides. So we're going to get y cubed equals x plus 5. And how would we get rid of that cubed? If it was a squared, what would we do? Right, so since it's cubed, we're going to take the cube root. Can't talk today. Yes, it is. We've done those this year already. Right, like at the very beginning of the year. Yeah. I mean, you're still doing it. You still, okay. It's fine. So then you get y equals the cube root of x plus 5. And you're done.
Is that really all, or is there like harder steps?
I mean, like, there's going to be lots of different types of equations. We're going to do an example of one that's a fraction next. Of like a rational function. Yes.
Why is not a fraction day? It's Monday.
Every day is a fraction day. We love fractions. Fractions are friends, people. Come on.
Have like fraction Friday instead of, and then have Monday, Tuesday, Wednesday, Thursday off.
No. All right. Are we good with this example? All right, let's do another one. So, we're going to find the inverse of, I'm just going to go ahead and write it as y equals, so 2x plus 3 over x plus 1. So, what's our first step? Switch x's and y's. So now this is going to be x equals 2y plus 3 over y plus 1. I don't know why I put it on the side. I'm going to move it. All right, so now we need to do what? Solve for y. So that means we have to get rid of that fraction, right? So I'm going to multiply both sides by y plus 1 because that's going to cancel it out on the bottom. So now that leaves me with x times y plus 1 equals 2y plus 3. Okay, everybody with me so far? Or still? Yes, okay. All right, next we're going to distribute that x through. So that's going to become xy plus x equals 2y plus 3. All right, so again, our goal is to be getting y by itself. So we want to put everything with y on one side of our equation and everything without it on the other. All right, so basically that means I'm going to be moving my 2y over here and my x over here. All right, so I'm going to erase the arrows. That's just more to kind of show you what we're doing. So I'm going to minus 2y on both sides. And then I'm also going to get rid of x and move it over here. So that will give me, I'm going to come up here and write it, xy minus 2y equals negative x plus 3. Actually, I'm going to write that as 3 minus x just because it will look nicer. You can do it either way, though. It doesn't matter. All right, so since these both have a y with them, what can we do on this side? Right, but then that's going to put us a y over here since we want to solve for y. How can we make those two y's into just one? We can factor, right? We can factor out a y. So like we can pull a y out from each of these and write it as y times x minus 2, right? Pulling out greatest common factors.
Wow, this is a lot of steps.
These are the longest ones.
Yeah, I've been
Never gonna reach.
All right, then you divide by x minus 2 to get y by itself. So then y equals 3 minus x over x minus 2.
I don't really understand that.
Yeah, I don't know
I
how
don't
you
even
come up, how do you come up with
Yeah, I had
these
no
steps?
clue that's how we were supposed to do any of that.
Yeah.
Me neither.
Okay,
It makes sense, I don't know how
but
you-
now you know, right?
Yep.
Sort of? Okay, let's talk through it again. So, we have y equals 2x plus 3 over x plus 1. Okay, so we have a rational function. So it's been a while since we worked with these, I know. So when you have something like this and you're trying to find the inverse, first of all, obviously switch your x's and y's. Then you want to get rid of that fraction. So you're always going to multiply both sides by whatever's in the denominator. Like every time. So that's going to cancel it out here, put it over here. Then you're going to distribute that variable through. And then you want everything with y on one side, everything without it on the other. Then you will always be able to factor out a y and then divide by what's left.
Is that like the whole process for every one?
Yeah, for all the ones that are like this, yes, that's how they're always going to work.
Okay, so I'm writing down the steps.
Okay, yeah, here.
So you switch the x and the y.
Yes,
You divide both sides by the denominator.
multiply both sides by the denominator.
Oh, that's what
Yep.
and then you distribute the x.
Yes.
Um,
So then distribute x.
and then after that,
Get everything with y on one side, everything without it on the other.
and then you just factor the y.
Yes. So then you'll factor out the y. And then divide by, I don't really know what to call that. I was going to say divide by what's left. Which is like this part here, obviously. Okay, and then the other thing we want to do is like we can look at graphs and determine if that function would have an inverse. which is really easy. So remember when we tested with the vertical line test to see if it was a function? To see if it has an inverse, we just do the horizontal line test. So that's what we'll do here. So let's say we have, so that's really testing if it's a one-to-one function. So basically a one-to-one function would mean that like it passes the vertical line test, so it is a function. But it would also have to pass the horizontal line test, which means that its inverse is a function. So like for this parabola that I drew, let me outline it in green. It is not one-to-one because its inverse would not be a function because it fails the horizontal line test. But something like, so even like something like this. Right, so again, it has to pass both the vertical line test, it passes the vertical, and this one is going to pass the horizontal as well. So this is a one-to-one function. Because it means that the inverse would also be a function. So you just have to test it vertically and horizontally and make sure it doesn't touch in more than one spot. So this one is a no, this one is a yes. All right, so any questions so far? Because that's really it for notes today. Okay, so on page 330, you're going to do 1 to 13 odd, and then 17 to 26 all. So the 1 to 13 odd is like the actual finding the inverse, and then the 17 to 26 is the graphs.
What page is it?
330.